Okay, so we're doing a question from Zumdahl and Kelter, the study guide. It's called Chemical Principles. In this question, which is a stoichiometry question, we're asked what happens when red phosphorus reacts with potassium chlorate. The question asks, a reaction proceeds between 94.6 grams of potassium chlorate and 65.3 grams of phosphorus, P4. What I've done is I've written the reaction, potassium chlorate reacting with phosphorus to form tetraphosphorus decaoxide and potassium chloride. I then had to balance the equation, and the way I balanced it was by looking at, I can take you through that. This is what I had originally. And when I saw that I had 10 oxygens here and 3 oxygens over here, I realized I had to put a 10 over here to get the correct number of oxygens and a 3 over here to get the correct number of oxygens as well. So I now had 30 oxygens here and 30 oxygens there. That automatically forces me to put a 3 in front of the phosphorus to get the 12 phosphorus before and after. And then I looked at the potassium. So I had 10 potassiums, I had to put a 10 in front of the potassium chloride. And then I double checked. I said, let's see, 10 potassiums, 10 chlorates. Well, I don't have chlorate anymore, so 10 chlorines, 30 oxygens, 12 phosphorus, everything checks out so that it's a balanced equation. The stoichiometry is 10 to 3, which means for every 10 molecules of potassium chlorate, I require 3 molecules of red phosphorus. Or I could say also, for every 10 moles of potassium chlorate, I require 3 moles of red phosphorus. So it would look as though when you do the calculation to find out the number of moles of each one of the molecules, we start off with 94.6 grams, we divide by the molar mass of potassium chlorate, and we find out that there's 0.77 moles of potassium chlorate. Using the same type of calculation, we find out that there's only 0.52 moles of red phosphorus. So it looks like there's less red phosphorus available than there is potassium chlorate. And in terms of raw numbers, yes, there's less moles of potassium of phosphorus than there is of potassium chlorate. But because of the stoichiometry being 10 to 3, the potassium chlorate is going to be used up more quickly. So it turns out that this is actually the limiting reagent. And to look at it another way, if we have 0.5 moles of red phosphorus and the stoichiometry is 10 to 3, or let's make it easy on ourselves, let's pretend it was 9 to 3, so you require 3 times as many moles. 3 times 0.5 is going to give you 1.5, and we don't have 1.5, we have 0.7. So we know that this is going to run out first. That's why I wrote this is the limiting reagent, and which means the other one is in excess. So we begin our calculation to determine the amount of potassium chloride, because the question asks how much potassium chloride is formed. We begin our calculation from the substance that's going to finish first, which is the potassium chlorate. So 0.77 moles of potassium chlorate times 10 moles of potassium chloride formed for every 10 moles of potassium chlorate used. That allows us to cancel the moles of potassium chlorate. So we get the same number of moles of potassium chloride forming, and then we multiply by the molar mass of potassium chloride. Here's the potassium, here's the chlorine. We predict that it produces 57.5 grams of potassium chloride. And then we are asked what is left over. So if somebody could shift over the camera, I'll go and talk on this board. We start by finding out that, again, we start the calculation with 0.77 moles of potassium chlorate. The stoichiometry is 3 to 10 now, which means for every 3 moles of phosphorus that's used, 10 moles of potassium chlorate is used. So we find out that 0.23 moles of phosphorus is used. Moving on to the next board. Moving on to the next board, we see that we had 0.527 moles of phosphorus to begin with. We used 0.23 moles. This is what's left. So we multiply by the molar mass of phosphorus, of red phosphorus, to get that there's 36.6 grams of the excess reactant left over after the reaction takes place. How do we find the percent yield? The formula is your actual yield divided by your theoretical yield, which we predicted to be 57.5 in the first part of the question, times 100. We're told in the question that you actually make 21 grams of potassium chloride over the theoretical yield of 57.5. That gives us 36.5% yield. Questions?